So now the problem with organic chemistry is, okay, it's you need to understand both things. It's very conceptual. Plus, at the same time, you've got to memorize a lot of stuff as well. So we're gonna start with the very basic, which is uh, so starting with the very basic stuff. Okay, what is organic chemistry? That's number one. Now, organic chemistry is the chemistry of carbon. It's the chemistry of carbon compounds. And where do you see these carbon compounds? These carbon compounds are uh, the entire chemistry of life. That's organic. It's all carbon compounds. You've got animals, plants, living beings, living organisms, all sorts. Okay, we are all organic. All our cells are organic. Our hair, our nails, they're kind of organic. So they're all carbon compounds. Skin is organic. Okay, so living organisms, plants, animals. So pretty much anything that's got to do with living organisms, that is organic chemistry. What do you make out of living organisms? The Earth makes uh, fossil fuels out of it after billions of years of compression. So all your fossil fuels, they are organic compounds. Um, your entire medicine industry, that's all organic. So the entire pharmaceutical industry, that's organic. What else? I mean, anything that's a lot of agricultural stuff, that's also organic. A lot of these, so a lot of the agricultural stuff, that's going to be organic. That's going to be linked to organic. What else? Your food industry, that's all kind of organic as well, because all your food compounds are organic molecules. So it's the chemistry of carbon compounds, right? So very first basic thing is we're going to learn how to write formulas of organic compounds. So when we talk about formulas, you've got all sorts of formulas. It's not just one type of formula. You've got many different types of formulas. So the first one is a molecular formula. So now you have to be very careful when you're answering questions in AS. They'll be very specific about which formula they're going to talk about. So the first one is known as a molecular formula. And when we talk about the molecular formula, it just tells you the total number of atoms of different elements in a compound. So no extra information is actually provided. That's it. For example, they might tell you that there's a molecule which is C4H8O2, or there's a molecule of glucose which is C6H12O6. Now you pretty much get nothing out of it. It's just the total number of atoms that are given over there, and no information whatsoever about the structure of a molecule. I said no information about the structure. And the second, so let's move on to the second one. Okay, this one is not, but remember, you have to be very careful if they're asking for, ये आपका molecular formula, you have to give the molecular formula. The next one is your structural formula. And this structural formula has many types. So basically, इसको highlight भी कर ले. अच्छा, basically your structural formula is any formula so basically your structural formula is any formula which gives you information about the structure of a molecule. So this one provides information about the structure. And this formula has many types as well. So it provides you information about the structure. Along with the total number of atoms, it gives you information about who's bonded to what. So some information about the structure will be given in the formula. So for example, at the first one, let's do the first one. The first one is known as a fully displayed formula. So that's a first one. So what's a fully displayed formula? Fully displayed formula is one कि जहाँ पे every single atom and bond is shown. So fully displayed, everything is shown. Who's bonded to what? So before drawing structural formulas, especially the fully displayed formula, I'll explain that carbon, remember, makes 4 bonds. I mean, these are the common elements that you will meet in organic chemistry. Nitrogen makes 3 bonds. It's a group 5 element. Oxygen makes 2 bonds. And hydrogen makes 1 bond. And then you've got group 17 halogens. They usually make 1 bond. These are the usual bond formation that's going to happen. These are the normal numbers of bonds that they're going to form. ये clear है? Is this clear, Ahmed? बाकियों clear है? Rafik?
Yes, sir.
Yes, sir.
अच्छा, so starting with the first thing, very basic. Learn to draw correct fully displayed formulas. So I've got this molecule, and there's let's say there's an OH, and there's a double bond O here. Now each atom must be making the right number of bonds. So carbon over here should be making 3 more bonds. It should be making 4 bonds. So I'm going to add in some hydrogens over here. अभी मैं randomly बना रहा हूँ molecules, ठीक है? This carbon is making 4 bonds, so that is fine. Oxygen should be making how many bonds? 2 bonds, that's fine. This carbon should be making 2 more bonds. This carbon should also be making 2 more bonds, ठीक है? So the first thing is, by looking at the structure of a molecule, you should be able to tell whether the structure is correct or incorrect. ठीक है? And this is a fully displayed formula where every single atom and every single, so remember this term fully displayed, सब कुछ show करना है. So I'm going to draw some wrong ones over here. Tell me if how to correct them. ठीक है? So अच्छा इस molecule में is it's a fully displayed formula which an incorrect fully displayed formula. Is this carbon fine? या कुछ गलत है इसके साथ?
One bond missing.
ठीक है तो carbon should be making 4 bonds, right? So let's add अभी तो randomly I'm just going to complete it by adding hydrogen. ठीक है? Let's say I've got a lot of hydrogen atoms. ठीक है? ये वाला ठीक है? Carbon next one.
No, sir.
ठीक है? And why is it wrong? Because it's making a total of 5 bonds. ठीक है? It should be making just 4 bonds. So I need to probably erase one of them. ठीक है? So that's gone. So then what about the next one? Is this fine?
No, sir.
ठीक है? तो again it's making 5 bonds. So let's get rid of this. ठीक है? So now the carbons are fine. Is the oxygen fine? Oxygen should be making how many bonds? Should be making 2 bonds. This oxygen should be making 2 bonds. The hydrogens and fluorines should be making 1 bond each. So now this molecule is correct. Is that clear?
जी sir.
Yes, sir.
So what about so okay, what about this? And it's a fully displayed formula where I show every single bond. So let's say I've got let's say मेरे पास H है. How many H should I add over here to this carbon atom?
1.
ठीक है तो इसके साथ there's going to be 1 H added. ठीक है. What about the next one?
1.
ठीक है तो again 1 H. अच्छा फिर इसके साथ भी 1 H होगा. ठीक है. It's making 3 bonds. Should be making. And this one should also have 1 H. ठीक है. How many H's should I add with this carbon atom over here?
Sir, 0.
क्योंकि 4 bonds complete है. What about with N? How many H's should I add with N?
1.
ठीक है. So I'm going to add just one more. N is supposed to make 3 bonds. This carbon is also fine. Now the structure is correct. ठीक है. Clear है ये बात हुनैद? राफे अहमद clear है?
Yes.
Yes, sir.
Just remember this thing, fully displayed. ठीक है. That's what fully displayed is. Then there's another thing which is called I mean it's kind of the same thing, ठीक है, except okay, remember fully displayed. Also remember one thing, okay, it doesn't really matter whether I mean the direction, this is not the actual shape of the molecule. This is not how the molecule actually looks like. This I mean a formula tells you the connections. Like it doesn't matter whether the H is pointing over here, or what can happen is that this H over here can be pointing downwards as well. It's kind of the same molecule. It's the same connection, right? So remember, this is not, I mean, you have to note down this is not the actual shape. So this is not the actual shape of the molecule. So it doesn't really matter whether the bonds are pointing to the left or upwards, as long as the connections are the same. For example, uh, इसको अगर मैं लूँ ना, इसको if I draw this like अच्छा I've got OH Now, look at these two molecules. Are these two molecules different or are they the same? क्या ये हुनैद, इबाद, अहमद, राफे, same or different?
They look the same, sir. As far as the bonds and the elements are concerned.
See, it's basically the same connections, right? So these two are basically exactly, I mean, these two are exactly the same. So, I mean, they have this exact same structural formula. So you have to watch out for this because it's the same carbon atom with OH and double bond O. It's this one. Carbon with F, that's this one. Carbon with two H's, that's this one with double bonds. It's everything matches. It's exactly the same. So they're just rotated, twisted versions. So remember this, these are not the actual shape of the molecule. The shape of the molecule depends on, I mean, the arrangement and the shape of the molecule. ये हम पहले कर चुके हैं. Okay, the shapes of the molecule, they depend on the number of bond pairs that they have. Okay, but we'll talk about that later. But okay, let's just do a quick recap, right? We did do shape, and yeah, if I can. So shapes of molecules or the molecular geometry. So this one. You can see better things again. So let's go with this one. As a molecular geometry was that it's like the image. This one. As a molecular geometry was that we learned that if you have two bonds, the molecule will look like this. The bonds are going to repel each other, so they'll be opposite to each other. If you have three bonds, if a molecule is making three bonds, it's going to look like this. It's going to be fan-shaped. I mean, its bonds are going to be 120 degrees apart. The bonded electrons will be repelling each other. ठीक है? उन्हें ये बात समझ आ रही है? Do you get this?
Yes, sir.
If you have four bonds, then the four bonds will be tetrahedral. It's all the bonds will be as far away from each other as possible, and they'll have an angle of 109.5. If you have five bonds, that's called trigonal bipyramidal, where you've got a fan in the middle and there's one bond on top of the fan and one bond at the bottom of the fan. And if you have six bonds, that will be octahedral. That means that the atoms will be arranged on all the axes. There's an x-axis, y-axis, z-axis. So all the bonds are going to be 90 degrees apart and they'll be on the axis. And then there were two shapes that were derived from the tetrahedral shape. That meant that if you had a lone pair and three bonds, then the lone pair is sitting on top, so it's going to look like a pyramid. There's nothing attached on the top except a pair of electrons. And you could have two pairs of electrons as well in the tetrahedral shape. Instead of two bonds, you can have two pairs of electrons. That will be bent. So just to give you a brief idea that this is how a molecule would actually look like. So remember, carbon is either going to be making four bonds or it's going to have three bond pairs when it makes a double bond. So on one side, there's going to be a double bond and two sides, there's going to be a single bond. So carbon has these two shapes, usually either tetrahedral or fan shaped. That's how carbon would actually look like. And let me draw this as well, that the actual shape, ठीक है, हमने यहाँ पे लिखा था कि so this is not the actual shape. We did write this down. Remember, carbon when it's making four bonds, it's going to look like this. It's going to be tetrahedral, which means that Okay, so it's going to be tetrahedral. That's how it's like a pyramid with one bond on top of it. And the angles would be 109.5 degrees. And when carbon is making a double bond, then it's going to be fan shaped, where one double bond will be on one side and the other single bonds will be. So it will be arranged in a fan shaped manner and the angle will be 120 degrees. Remember, carbon will normally have these two shapes. Okay, we're not discussing shape at the moment. Fully displayed. Okay, we're done with fully displayed. The second one is, the second type of formula is, that's a condensed structural formula. So what happens in a condensed structural formula? And when do you use condensed structural formula? If you're running out of space, I mean, that's the basic reason for using a condensed. So whenever you're running out of space, you condense the structural formula. For example, if I have a fully displayed formula, and let's say there's a carbon chain with, and maybe there's an OH group attached, and these are all your hydrogens. Or again, let's say I've got another C. Now, as you can see, this kind of takes or consumes a lot of space. So what you instead do is you condense it. How do you condense it? You just go from in one direction, which is usually left to right. Okay? You just follow the left to right direction and you write down everything that comes in your way. Okay? So we're going left to right and we're going to write everything that comes in the way. Starting with the first carbon atom, I'm just going to write down whatever comes around this carbon atom, whatever comes around this carbon atom, whatever comes around this carbon atom, और फिर ये वाला, ठीक है? So starting with the first one, ठीक है, we're condensing it. First one, carbon, it's got 3 H's, so that's C, H3. Starting with the second one, it's a carbon again, and this carbon has 1 H next to it. It's got 1 H. Any branch that's coming out of it, going on towards the top or the bottom, that's going to be written in brackets. So we had a first carbon atom, and now we have a second carbon atom. ठीक है, the second carbon atom is CHOH. ये clear है सारों को?
जी सर.
Yes.
So then you've got the third carbon atom. Okay, let's move to the third carbon atom. The third carbon atom has an H. And remember, there's this whole thing coming out of it. You're going to put this in brackets. It's going to be what? You're going to condense it as well. It's CH2 and CH3. You can even condense it further as well as C2H5. So the third carbon atom has this third carbon atom has all of this stuff attached to it. It's got an H and it's got this thing attached to it. And then you've got the fourth carbon atom. Okay? The fourth carbon atom is going to be one with just having CH3. Okay? So is this clear that this over here is your condensed version? Okay? And the reason you use a condensed version is, okay, if you're running out of space, if you want to write the whole formula in just one line, so you're going to use a condensed version. Is this clear?
जी सर.
All good, sir.
And then chalo. फिर ये कि so we'll just practice a bit more कि let's just practice one more question maybe similar to this. It's so I've got this molecule with double bond O, and it's got let's say another double bond O, and there's an O, and then it's got a carbon with 3 H's. It's got a double bond. And what else? Let's just add 3 H's to it. So anyways, condensed version of this thing. So what we'll do is we'll just go in one direction. I mean, choose your direction, just stick to it. Okay, it doesn't really matter what direction you choose. So starting from left to right, you could choose right to left as well. So this one is CH3, C with 3 H's, the first one. The second one, C with O. The third one is again C with O, and then there's another O. So those are your first 3 carbon atoms. So the third one is C with 2 O's, and then I've got C, and it's got this CH3 branch. So I'm going to put that in a bracket. And we've got double bonds. As in condensed versions, usually you do write double bonds. I mean, you can choose to avoid writing that double bond, but usually you do write carbon and carbon double bonds just to show where the location of the double bond really is. So are you clear? This one?
This.
So, sir, we ignore the double bonds between the O's.
Yes, we kind of do. And then and also remember there's a lot of in between stuff as well. There's going to be some of it is going to be displayed, some of it. So there's going to be a lot of formulas which are going to be kind of in the middle. It depends on your convenience, right? So so you're going to have displayed plus condensed at the same time. Some of it displayed, some of it just to save time is going to be condensed. So you will have that as well. So for example, if you have, you will think I've got so I've drawn a displayed version right now, but I don't want to draw. I just want to save time. I don't want to draw all the H's. So I'll just do a mixture. Like how many H's with this one? It's going to be 3 honge. So how many H's with this one? That's 2. How many H's will go with this one? That's going to be 2. It's already making 2 bonds. This one is making 3 bonds, so it needs just 1 H. This one is making 3 bonds, so it also needs just 1 H. It needs 2 H's, and I guess this one also needs 1 H, right? So this one is kind of an in between. It's a displayed as well as a condensed. Some of it is displayed, the rest of the part is condensed. Is that clear?
जी sir.
Yes.
That's a condensed. Make sure you remember this as well, that in condensed formulas, there's a thing called this thing, which is this thing is an aldehyde. Now the condensed version is going to be written for this one is going to be RC and HO instead of OH. That's how you're going to write. I mean, this thing is an aldehyde. We'll study that later, but remember this. This is not called OH. Instead, it's called HO. which basically because OH is like an alcohol, it's so to avoid the difference between OH, I mean you had an OH over here as well, right? I mean this one was COH, right? CHOH, right? So just to differentiate whether it's an alcohol or is it an aldehyde, you instead write this as an aldehyde. Is that clear?
जी सर.
Yes.
तो ये थोड़ा सा याद रखना है कि
Is this a new family, sir, of
it's a new
organic
family.
compound?
We'll study that later, but just right now, learn this fact that cetyl bond OH is going to be written as CHO, not OH. Is that clear?
Okay.
चलो ठीक है. We'll do the other type of formulas tomorrow then, ठीक है?
Okay sir. Allah Hafiz.
चले, okay everyone, take care. Office.
Sir, could you send the new board link for these notes, sir?
ठीक है, I'm sending these. 1 second.
Okay. Thank you, sir.